are back with another wonderful episode, and we have the one, the only Draw Curiosity as our guest. Please introduce yourself as little or as much as you'd like.
Hello, everybody. Well, my name is Dr. Ines Dawson. I always say Ines rhymes with space or with face. And I run the Twitch and YouTube channel Draw Curiosity, where I make plenty of science content, which is a lot of biology crossed over with engineering. And my STEM background is in biomechanics, specifically insect flight biomechanics. So I always say I'm a doctor, but not the sort that can save your life.
Fair. I can attest to that. That the same kind of doctor definitely can't do. I'm in the wrong field completely. At least you know something about biology. I wouldn't know anything. So you're okay. If you're allowed to share, could you describe your education background? Bachelor's, master's, PhD, whatever it is, MD or not MD in this case.
Definitely not an MD. So bright-eyed and bushy-tailed, I went into an undergraduate, a Bachelor of Arts in Biological Sciences, because that's how they do it in
Oh,
Oxford.
interesting.
And then I stayed on to do a DPhil in interdisciplinary bioscience, which also, again, Oxford just couldn't call it a PhD. They had to give it its own term, Doctor of Philosophy. And I stayed on basically in the same place because I've always loved insects. And I liked the idea of doing biology, but crossed over with a slightly more mathematical and coding background. And so
Mm.
engineering felt like the perfect fit. This was all quite a long time ago. I started my education in 2010. I graduated over 6 years ago at this point. So I feel like I've been out of the PhD for longer than I was in it.
Okay. And did you continue research after your PhD?
I did not. So I basically graduated into the pandemic. And
Okay.
I did always know that science communication was my passion. So I started my YouTube channel whilst I was doing my PhD. And I took a bit of a break from it. I was very burnt out after the PhD. And
Understandable.
also, I sort of took a sabbatical. I moved to another country. Then COVID happened. So I just ended up taking a very protracted break from everything, sort of science and the internet. And then like slowly returned, but the urge to research again has not quite returned. So I haven't I got my letters at the start of my name and was like, I'm done.
Fair enough, fair enough. And so you have been focusing mostly on science communication then via Twitch and via YouTube ever since. Is that fair to say?
Yes.
Okay. So to go back and to talk about your insect love and your what your PhD research in and it's in biomechanics. Well, listen, I'm no that sounds like biology and like physics mechanics put together. So that's if I'm right in understanding what it is. Could you explain a little bit more about what your PhD is and what is fly biomechanics?
Absolutely. So I specifically focused on, or my actual thesis title was Free Flight Kinematics of Dipterans. So dipterans are the true flies. They only have two pairs of wings. So think your fruit flies, your blowflies, your house flies.
Oh.
Mosquitoes also flies, although I was not studying mosquitoes. So dipteran literally means two wings, and that's because their back wings have are halteres. They aren't real wings; they're modified wings, and it provides the insect with very high resolution data about its positioning in the air. So they are very agile flyers. Kinematics specifically refers to the study of how things move. So I
Mhm.
was particularly interested in how they move their wings and how they move their bodies, and is quite distinct to aerodynamics, which is a massive headache. And then free flight. So a lot of early flight studies, it was kind of hard to be able to research an insect in free flight. So we would often tether them, but one could argue that that is not the natural way that an insect would fly.
You put a
So
rope
we
around a fly? Did you
There are
lasso
people.
them like a cowboy?
I love the idea of lassoing
A
a
fly
fly.
mid-flight.
It would be a little bit more metal. We would probably, if I have done tethered experiments with locusts, and we would just glue them onto a stick. But with the flies, we had like this very sophisticated setup with lasers.
Oh.
So basically, when they went over where both lasers crossed over, which happened to be where all of the high-speed cameras would be pointing, it would trigger a recording. So
Oh, okay.
when I when I want things to sound like I had a very cool PhD, I'll say, "Oh yes, I worked with lasers and high-speed cameras, and do all these safety talks and had to wear laser goggles." And when I want people to know the true meaning of doing a PhD, I'll say, "Yeah, I spent 3 months from 8 to 5 p.m. in a tiny room with black walls and no windows, and
Trying
also
to take
lasers and high-speed cameras."
trying to take pictures of flies.
Yes.
Makes sense. So, okay, so you were that's how you were capturing their movement. And were you, so there's a lot of things to talk about, I suppose, in the sense that were you studying motion or like, let me phrase this question properly. Was it a statistical analysis or was it pure observatory, if that's even the term I'm looking for?
It was a little bit of both. So I
Okay.
feel, if I'm being very honest with myself, probably the most valuable thing that came out of my PhD was some very, very large, high resolution data sets of two different species of fly, which would probably be, which I know, in fact, not probably, they have been used in other studies. But I did perform some analysis myself.
Okay.
So I focused primarily on three species of fly. Two of them were data sets that I collected. One was a ginormous data set that my supervisor collected. So I worked with fruit flies, I worked with blowflies, and I worked with a data set of hoverflies.
Okay. And it was purely statistical, or what kind of work did you do with the data?
So let's see, remembering what I did in my PhD. So fruit flies actually use their wings during courtship. So one of the
Okay.
studies that we were trying to do, there was a preliminary study that I was sort of involved in where they had genetically modified flies with slightly different wing shape,
Okay.
and they assessed whether the slightly different wing shape would affect how fast they could turn, how fast they could fly. And in summary, our actual wing shape is slightly different, is in such a way that the males are better at making a courtship song to attract the female than they actually are at flying. But obviously, sexual selection can often be a stronger selective pressure than natural selection, especially when it comes to, flies that you're keeping in a test tube and they aren't
Mm.
actually exposed to any predators.
Yeah.
So, so what I then went to look at was to see if there were any functional differences in the kinematics between male and female flies. So we had this
Ah.
data that analyzed how well they flew. I did a very short project where I basically got to play Big Brother with the flies, and I would see how quickly it took for the male to court the female, and I would record their songs, and I would time how long they would be copulating for in relation to that, and then essentially conclude, do they have a better performance depending on what shape their wings had? And then we also know additionally if those wings meant they could fly better or not. So basically, yes, the male flies are better at attracting females than they are at flying.
I see. So they had to give up their flying skills so that they could they could attract more females. Singing more important than exactly, exactly. Who needs wing efficiency if you can get? Okay, I won't finish the sentence there. You said something interesting that you said that you studied true flies. What is a non-true fly?
I guess I just figured I would. make sure we don't confuse it with dragonflies, butterflies,
Ah,
mantis flies,
okay.
everything else that's not actually a dipteran. So,
Okay.
and then to be fair, there are nematoceran flies, and I don't know why I'm blanking on the name now, but this is probably what I'm calling true fly, but the non-nematoceran flies, which are the flies that most likely have a gearbox system. So this is what we were
Oh.
looking at in blowflies. So they have some parts of their wing anatomy. They have an allula, and they have a very rudimentary gearbox system. And from tethered experiments, we know that they produce a slightly different subset of kinematics depending on how they join together. So they'll sort of have various positions where the gears can grind together, and that will enable them to have a larger or a smaller amplitude as they're flapping their wings. And we know that those tend to be associated with different flight behaviors. So I was trying to use a data set that we had collected with the same flies but on tethered flies. I trained a, a little machine learning algorithm to see if there would be a way of predicting this in the free flight data and if we could make guesses as to which gear they might be flying in and if
Mm.
there was a big overlap in similarity or not. So it's very experimental. It wasn't perfect because there's no way of verifying this. And this is one of the problems with certain machine learning approaches that don't where you can't actually verify the data after. So it was more of a hey, this is a fun thing that we can look at, and maybe in the future we could pioneer a way to be able to verify this. Because if it does work, this would be a good tool for us to then collect free flight data and find out this information about the
Yeah.
gearboxes.
Like when you said gearboxes, how does that? Sorry, I know what a gearbox is from turbines, from planes, whatever it is. What do you mean a fly has a gearbox?
So at the very base of the wing, they have several pieces of their wing anatomy that can either attach to one another. So it has a couple of
Oh,
grooves, and depending
wow.
on which groove attaches, or it might be free entirely. Sometimes it also attaches on the other side. We think that's potentially kind of a mistake in flight when that happens.
Oh.
But essentially, there are four positions they can be in, and especially when the grooves are clicked in place, it essentially affects the trajectory of their wing. They still have a lot of there are a lot more things that control the way their wings move than just that. They have plenty of torquing muscles. They're able to uh have a large amplitude when
Mm.
flapping or a small one. It affects their stroke amplitude, which is the angle relative to the ground at which they flap. So there is a lot more going on, and the gearbox is only a small element out of all of the ways that they can control their flight. But
Still, such
it
cool
was very exciting.
mechanic. Yeah, like quite literally in your research, you said that you study the biomechanics. It's literally putting the mechanics and the
Yeah.
biology there, like, isn't it? That's incredible. And this was only specifically to the blow fly, right? Not the fruit fly. So it's only a blow fly that has this.
So fruit flies are kind of too small for
Oh,
us to
they're
be
very
able
hard to
to.
see.
But that I don't think they do. Hoverflies, I think, do have potentially a rudimentary gearbox, but don't quote me on that. They
Mm.
certainly have an allula, and the allulas, if you look at a fly's wing, there's like a little flap at the bottom that they can flop out and increase their surface area or flop back in.
Oh,
And we also
wow.
know that that affects their mechanics. Although the Alula was not something that I specifically looked at. So the very last big study that I did, I did unfortunately have to do a little bit of aerodynamics. I spent my entire PhD trying to matrix dodge aerodynamics because no one wants to do it. CFD is the enemy of the people. But uh, I got all of the data sets, and I obviously had all of the kinematic data. And there are certain equations that we can use and adapt. So I'm sure everyone's heard bees shouldn't be able to fly because their wing surface area is too small for their bodies.
Because they're too
And
fat or fluffy.
they're too
Big
fat, they're
boned.
too fluffy. And look, if you were to grab a bumblebee and you were to make it the size of an Airbus and it didn't flap its wings, then sure, it would not fly. But the reality is, the size difference makes the smaller you are. Basically, if you're anything kind of above this size and flying, there is something known as the Reynolds number, which is a
Ah.
dimensionless number. It measures the ratio of inertial to viscous forces. Essentially, it's basically how much at the mercy of the viscous forces of the air are you. And the smaller you are, the more the air is like water, basically, or thick
Mm.
treacle or honey, depending on how small you are. And so the way the fluid interacts around you matters more. At a very, very low Reynolds number, such as bacteria, you have what's called Brownian motion. And
Ah.
essentially, when you're moving through that, if you're moving through something so viscous, if you stop, you would drift for less than an Armstrong, I believe. So a swimming bacteria can stop and it immediately stops. Whereas you can think something like a car or an airplane. If it stops, it's going to drift for quite a while until it finally comes to a halt. And that's because its inertial forces are greater than its viscous forces.
Okay. I knew of all the terminologies you were talking about. Obviously never knew it applied to all the bees. But also just to highlight Spooky, thank you so much for using the redeem question. So if anyone has any question for Draw Curiosity, make sure to use it so this way it keeps logged. Speaking of an ages ago, Lies on the internet asks, "How you doing, Doc?" That was the first
Ah,
question.
okay, I'm doing well.
um,
I am doing well. It's very early. Well,
it
not
is
really.
very.
I'm just night out.
Spooky asks, "Can you emphasize to Tofu how important air resistance is?" Is just a bit of a joke because I always or ignore air resistance in physics. Air resistance is not a real thing. It is not my concern.
It is it is pretty ignorable. But actually, when it comes to insects, insects lie at the intersection of very turbulent flow, where you would have your planes and your birds, and Brownian motion. So they are just a headache because everything matters. And that's the so you can't just take your equation that you would apply to birds and that you would apply to airplanes. You have to account for the fact that directly before, the way the air is interacting with the insect has changed in a manner that could be described as chaotic, but where you can predict what's going to happen next. And
Mmm.
the fact that it is time dependent, you can technically use the equations that you're not supposed to use as long as you're accounting for the fact that the wings are moving, the angle of attack is changing, and that over the course of a wing beat, you're going to want to integrate the difference to how that wing beat changes over time. So you can make a pretty good approximation. And when you do that, then yes, it does show that insects are able to fly.
Okay.
So I did a little bit of that with the kinematics, and the interesting pattern that emerged is that the kinematics was very correlated with their ecology. So, ecology refers to essentially how a species interacts and behaves with its environment. So, a fruit fly, for example, primarily tries to, uses its wings to mate with other flies. It doesn't do anything particularly fancy in the air. When it's flying, it's kind of traveling from point A to point B. Hoverflies are very territorial, and they, as their name implies, they hover. So they're very good at sort of staying in one point and rapidly darting around.
Oh, okay. I
So their kinematic. Oh yeah.
no, no, it's just I didn't even click the name hoverflies. Yeah.
And so a lot of the way their kinematics work allows it such that they can very easily balance the forces both back and forth, so they don't easily get as much forward momentum unless they are deliberately flying forwards, in which case they will angle the stroke plane angle of their wings. So essentially, they will
Okay.
pitch and change their body shape, their body angle in order to be able to do that. Blowflies don't hover. They kind of just fly as quickly as possible wherever they need to go. So all of the kinematics that we observe, the way their bodies are angled, the way the stroke plane angle, aka the angle of their wing beat, either compared to their body or compared to the ground, is very much correlated with what we would expect for kinematics for a fly that wants to hover or a fly that wants to primarily fly forwards. But the aerodynamics is a lot more correlated with their size. So fruit flies are very, very tiny compared to blowflies. Their Reynolds number is something around 120, sort of between 100 and 150. So they are much more at the mercy of, the viscous effects of the air. And so
Wind.
their aerodynamics of the wind,
Yeah, I was
of
gonna
the
say the
air.
wind is
Yeah,
gonna
yeah.
completely a little gust goes shush. Anyway, sorry, keep going.
Pretty much.
Apologies.
Like the way their wings work, it's a lot more like an oar, like a kayak oar through the air
Okay.
than it is, like actual flying. And the smaller you go with insects, the smallest insect I think is the fairy fly, which is actually a wasp. It is about two
Oh,
millimeters or maybe zero point 0.2. I don't remember. They're very tiny. Its wings are so small that it's basically a paddle with hairs. It's like a comb through the air, and it essentially is like kayaking your way through honey or through
okay.
treacle. Uh, Blowflies have a Reynolds number of around low thousands. So there is a little bit more inertial forces from them that come into play. And so the aerodynamics of hoverflies and blowflies is actually relatively similar because of their increased size. So it was very, I mean, it feels pretty obvious, but it was very interesting that the actual aerodynamics was very much at the mercy of their body size.
Mm.
But the kinematics varied a lot and tied in to their ecology. And this matters because let's say you want to design a teeny tiny drone that is modeled off insect flight because it's easier to model it of
Oh,
biology.
yes.
What do you want your drone to do? If you want it to hover, you're going to want the hoverfly data set. If you want it to fly quickly, you're going to want the blowfly. If it's going to be very teeny tiny, you're probably going to want to see how the fruit fly flies. So it matters. It's less about the aerodynamic regime and more about how what you want it to do. And so that was why the kinematic study was interesting and why the comparative effect mattered. Also, I told my advisors anyway.
No, that's amazing. Have you been keeping tabs on how bug drone technology has been developing at the moment in the last? Because that sounds like an episode from Black Mirror, honestly.
So it's been a while since I've kept up, but we would go to conferences where we would a lot of drone development is military and defense
Hmm.
funded. So there would be conferences, technically confidential, but a lot of the things that we saw have now been published. So generally 1 to 4 years ahead of when you see exciting mini drone news come out. That was probably being researched and showcased at a conference. So I can tell you what was happening in 2018, 2019, which was the last time I had, direct
Mm.
contact with that. And what I will say, we probably don't have to worry too much about Black Mirror in the short term because the main challenge to us designing silicone based drones, so to speak, is that we can't power something that's small.
Mm.
I'm sure there's smaller drones now, but I had at the time the smallest commercially available drone. It was actually very cheap. It's about this size, about 3 centimeters across. It takes 40 minutes to charge it, such that it will fly for about 3 to 5 minutes. Take an insect, it can feed for 5 minutes and will be able to fly for 40 minutes to an hour. We just don't know how to make batteries that are that small, that don't weigh very much, and that can power something this tiny for a long time.
Mm. something maybe in the future of like directly not so much as the battery but direct sunlight, you know, but again that kind of defeats the purpose in a lot of countries where we don't have the sunlight. It's always limited to
Well,
sunlight.
that's actually a very good idea because I think it was RoboFly. So there was a lab that designed RoboFly, which is literally the size of a fly. It kind of reminds me of a tiny IUD with wings. That's the shape of it. But it doesn't have a battery on it. The way they power it is they
Hmm.
point a laser beam at it, and the energy from the laser gives it enough power to flap a few wing beats. Of course, then it is no longer in the path of the laser and it lands. So it's a proof of concept. You can power it, but you basically need a laser trained on it. So I actually think that solar powered
Ah,
would probably be more effective because at least there'd be a more, at least in a sunny place, a more constant
constant.
way of powering
Mhm.
it.
Yeah.
But of course, if it has to be indoors, or if there's clouds, or if there's weather difficulties, then it would not work.
To get a bit off topic, I've just a question about like whether it be the gears or the mating dances or songs of flies. Is there anything like from an evolutionary perspective that's interesting that you know about these flies? I know it wasn't specifically about your PhD or research, but I'm assuming that you do know a lot about these flies anyway. Is there anything cool evolutionary wise that you know about them?
So when I was talking about the nematoceran flies versus non-nematoceran flies, this is just a very random observation, but I've always thought it was very cool. So I mentioned at the start, dipterans, two wings.
Yeah.
All insects theoretically have four wings, but sometimes one of those pairs of wings are modified. The back ones are
Okay.
halteres. They look like little gyroscopes. They have a thick end and they kind of boing around, and it sends them information so they know what position they are in flight. With the non-nematoceran flies, which are the ones like house flies, blowflies, the ones that we think of as, you know, the flies that kind of know what they're doing. They can land upside down, they can fly backwards, they're very agile. The way their halteres flap are always perfectly out of phase with the wing. With nematocerans, even though the
Oh,
way they flap might be fixed, but it's always out of phase. It's never exactly out of phase, but the actual angle at which they flap is very different.
okay.
And I think that ties into why they aren't as good at
Okay,
flying.
they look clumsy doing it. Okay.
Yeah, if you think of a mosquito, think of, you know, a crane fly. I mean, they can fly. They're certainly, you know, versed in the ability to fly, but it's far less precise. And it's always been an interesting quirk that the way that their halteres move
Mm.
is substantially different. Obviously, we know that the true flies have this gearbox system as well. They have a few additional adaptations and traits that have evolved too that ties into them flying well. The other thing that I always like talking about with insects, but this isn't really specific to flies, I always like talking about the difference between direct and indirect muscles. So, dragonflies have direct muscles, and what that means is their flight muscles attach directly to the base of their wings. And so, dragonflies can move each one of their wings independently in any way.
Mm-hmm.
It makes them very agile,
Ah,
but it limits the maximum speed at which they can flap their wings because it's limited to how often they can send a signal, which is about 30 times a second. Take indirect flight muscles. Indirect flight muscles don't attach to the wings, they attach to the thorax. You have a set of vertical ones and you have a set of transversal ones, and they contract and expand in an alternating fashion. So, this makes their thorax change shape. When you hear a bee buzz, it's not actually their wings, it's the muscles
ah,
vibrating.
okay.
So this causes resonance, and the resonance then makes the wing flap.
Hmm.
Because you have muscles that are being activated transversely, and because they're activated transversely, they're able to not use as much energy. And certain insects I believe coleopterans, dipterans, and there's one more, and it's evading my mind right now. But they also have what's called a synchronous muscle. So the synchronous
Ah,
muscles is one nerve impulse equals
one.
one muscle contraction. Asynchronous, one nerve signal equals multiple muscle contractions. And this is how you get flies that can beat their wings 150 times per second, even though the nerve impulse is around 30 hertz.
Hey, I like it because there's a lot of like electric grid and synchronous generator talk as well. With
Yeah.
this, I'm applying my PhD here to flies, which is absolutely brilliant. So just a friendly reminder, if you guys wanted to use the redeem question, go ahead because I'm going to go through the questions really, really quickly now. Shackle asks, Doctor, can I get the pronunciation? Ines?
I would say Ines rhymes
Ines.
with face or with space. Yeah.
Ines, Ines. Lovely name. Which bug is the best bug? So a fly isn't a bug, right? Oh, a praying mantis!
Yeah. Well, it's not a true bug, but I will accept bug as definition of generic insect. If we're talking true bugs, which would be hemipterans, and interestingly, true bugs don't undergo full metamorphosis. They're born as miniature versions of themselves. And if I had to choose from those, I'd probably go with one that we have in Europe called the firebug. I'm going to try
Firebug.
and pull up I'm going to try and pull up the Latin name for it. Pirocoris apterus.
Oh, it's very pretty. It looks kind of scary. Is it poisonous?
It is not poisonous. It is super common and there's a lot of very interesting research. So the ones that are found near the Chernobyl area have some very interesting
Oh.
mutation effects. And so you can actually measure the level of radioactivity in areas post Chernobyl based on how messed up those bugs look. And then there was another story, which is one of my favorite stories of all time. There was, I think it was a Czech lab actually. They worked on these bugs and they moved the laboratory over to Pennsylvania. And they encountered this problem where their colony of these bugs, of these firebugs, generally they molt 5 times. And after the fifth time, they go from a miniature version of themselves to a reproductive version. So
Okay.
after the final molt, they are sexually active and they have wings.
Hmm.
That's kind of the main thing that happens. But they would just molt again and they would still not have wings and they were still juveniles. And then eventually they would pass away of old age, but they would just molt forever. And they spent the longest time trying to find out what on earth was causing this. What was in American water that was preventing these
Yeah.
European bugs from flourishing? And they altered everything about their setup and they found out that it was the napkins. It turns
Napkins?
out, yeah, they would put napkins at the bottom of the terrarium so they could spray water on it so they would have a humid environment. In the US, the vast majority of napkins are made from the birch tree, and the birch tree
Oh.
has a chemical compound that's very similar to the juvenile hormone in these beetles. So essentially, I guess they had the equivalent of a beetle puberty blocker. They just would not be able to
Wow.
express the genes to develop wings and become reproductively active. And it's interesting because this hormone is extremely different and specific across different insects. So the juvenizing hormone of certain butterflies is completely different to the one of the firebug. But there are certain pests that are very similar to the firebug, and I've always wondered if you could use birch napkins to try and prevent them from becoming adults and prevent pest infestation. It's obviously a little bit
Yeah.
more complicated than that, but it's a story that always tickled me because I don't know what they actually researched generally, but they made very interesting findings about the hormonal basis of what turns them into adults from this little accident where they brought the firebugs over to the US and they just couldn't raise a colony.
Yeah, I find that point really interesting they made about pesticides, right? Like if you could stop from them basically becoming adults at any given point or reproducing, basically, you could really, yeah, very interesting. I wonder if there's been research being done in that area.
I would say Wolbachia, which is a symbiotic, oh, sorry, an endobacteria symbiotic asterisk. Some might not call it symbiotic because it prevents the insect from being able to reproduce. That is probably the more effective way. Because what I will be honest and say is that I'm not certain if you have to be constantly exposed to this hormone. Because if you're
Mm,
only walking over a birch chip, but then you walk away where you don't have that, then
mm,
presumably the effect of that hormone would dissipate, and then you would be able to molt and become
mm,
turn into an adult. So that is the one caveat to it. But there are certainly other methods that people have investigated to look into
mm,
population control, and Wolbachia, which I do have a video on my channel about, is one that
mm,
people generally use to try and control mosquitoes because obviously due to climate change their range is expanding, and they are actually, even more so than humans, the deadliest animal on the planet and a vector to many, many diseases.
mm. I need to probe that a bit more. Just to finish, in, because this was a question, to go back on the praying mantis, why it obviously you were saying like technically it's not a bug, but how come praying mantis is your favorite? I know the story, and people have corrected me about the fact that the female praying mantis, as she finishes getting her eggs fertilized, will bite off the head of a male. But supposedly, I've heard that that's not true. That was only observed in captivity. Is that fair to say? Do you know more about this?
It's slightly more common in captivity. So something that's quite common with many arthropods is the male will provide what's known as a nuptial gift for the female. So they will capture an animal, well, capture an insect generally, or some other arthropod, and they'll feed that to her. So while she's busy chomping on this tribute, then they will copulate with her and provide her with the sperm. And the nuptial gift will, go towards her having more energy in order to be able to raise the eggs. Of course, in captivity, there's less guarantee that the male is going to come to the female with a nuptial gift. So then
He becomes the
the nuptial
gift.
gift. Precisely. There's also things that have been said that, removing the head helps uninhibit the male. So he is, I don't know, able to spasm more and deliver his entire spermatheca. But honestly, the insects are pretty cruel to their males. I recently also worked on this video called "Everything Wrong with Bee Movie," and I I always talk about, females are the only ones that sting because the
Oh,
stinger of a bee is a modified ovipositor, and only the females have that anatomy. So it's a modified ovipositor. They have venom as well, but it's also what they use to lay eggs. When you
oh,
take so the males don't sting. However, the males can also die because when they mate, instead of a stinger falling off, their endophallus, aka their penis, falls off, and they donate it to the future queen so that she'll be able to take all of his sperm and hopefully sire as many of the worker bees and hopeful future queens in the hive as possible. So when they say that male bees generally pass away shortly after reproduction, I previously thought it was because the males were jettisoned from the hive, which is the case for bumblebees. But in the case of honeybees, they do literally give away their manhood, and that's it.
listen, ladies, our standards are not high enough. Bees literally sacrificing for their queen. I'll have a chat. I'll have yeah, yeah. The random facts that we're getting here is absolutely brilliant. Have we managed to adopt the method of flight of flies into aircraft? Asks Azir, even if it is at a small scale level. So I think this was kind of before or around the time we might have been talking about drones. But what about pure
Yeah.
flight? Technically, are they two different things? They are technically two different things, drones and flight.
Yes. So drones are usually rotor based. I would say a lot of what is specific to insects doesn't really apply once you're in a fully turbulent regime, because the adaptations that insects have is basically what enables them to contend with slightly higher viscous forces. So, ironically, I would say it might apply more maybe to boats or anything that would travel through water. But I can
Ah.
tell you about other weird drone things that people have done. There was one that was quite striking to me. It's a bit freaky. It was kind of a Frankenstein drone thing they did. They took they built a normal drone and they would use the antennae from a moth, because moths have very, they have these very plumose antennae, which also have very interesting biomechanics, which is a whole separate topic as well. Similar but different. They're feathery, and the spacing of the feathers is enough that the air can pass through, so it can't be too viscous that it goes around, but there have to be enough of them that there's plenty of surface area for them to detect chemical compounds. So they used the nerve impulses from this antenna to feed information into the drone. And so they would make this drone hone in on the scent of something. So they would have this perfumed jar of water. They would put the antennae on, and the drone would basically, much like a moth would, find its way. Cue with the part at the end where they rapidly have to rescue the drone before it collides into the water and dies forever, which added a little bit of comic relief to it. But I actually thought that was a very interesting application of things that insects do and that we know they do well, and we understand the the nerve signals very well, and we were able to apply that
Mm.
to an electronic interface.
Yeah, that is really cool. Kind of little addition to it. Sorry, Tarek had asked a similar question. He was just highlighting it there, that he did ask a slightly similar question there. On the same topic. You were talking about the Bee Movie a little bit. You did a YouTube video, is it, on the Bee Movie?
I made it for April Fool's Day. It's called Everything Wrong with B Movie. It ended up being 30 minutes long. And it is starting to go slightly viral, or at least like the last couple of days. There've been way more comments coming in on it, but I watched it with a very critical eye and annotated the whole movie and did way too much of a deep dive, because some friends made me watch B movie a number of years ago just to watch me rage at everything wrong with it, and I thought it would be funny.
There's the link. It's posted by Shackle, I believe. It is something I'm just going to open in the tab here, and I will check it out after this video, which I think is really, really good. We will do that. Speaking of movies, have you ever seen I think it's called The Fly, with what's his name?
I
What's his
haven't watched The Fly,
Jeff
but I
Goldblum. There we
know
go.
I haven't watched it, but I know someone whose granddad worked on the movie because he made the makeup that
Oh
was
my
used to
god.
do the makeup in The Fly.
No.
So I have not watched it. I watched Jurassic Park recently. I hadn't watched it since I was a kid, and I was slightly tempted to. What if I establish parallelisms between Jurassic Park and the new Direwolves paper that came out? Or what if I start a series with everything wrong with insert science-based movie?
Well, with the success of the B video that you posted, maybe I think the Fly movie, it's a bit gory. I don't know how much of a fan of horror you are. Now it is like 80s or whatever, but it's still very gore. I would say it freaked me out a lot. So the makeup, yeah, exactly.
Okay.
The makeup and prosthetics were amazing. So I highly recommend, especially as a person who's a fly specialist, to watch it. But it is horror. I don't know if we should. Yeah, yeah. Uh, Watch it at your own caution.
Will
um,
do.
yeah. Lint asks, not too long ago, a complete model of Dros. Okay, sorry. Let me read this properly. Drosophila melanogaster brain was built. Can this model be
Yes,
used to study the fly's flight control in a computer simulation? Sorry, could you translate the question to me?
Yes, so it says not too long ago, Drosophila melanogaster, the fruit fly's brain
Ah, the fruit
was
fly.
built. Can this model be used to study the fly's flight control in a computer simulation? So, LintTech, on my channel, there is actually a highlight in the science
Oh.
section, which actually goes into this paper. It's called like full model of a fruit fly's brain. Uh, the model, I believe, is a connectome. So what they did was they scanned the brain and they look at how all of the neurons connect together, and they have all of the neurons labeled in terms of whether they are sensory neurons, motor neurons, etc. We I don't know specifically for Drosophila, but probably yes, because it's one of the most studied organisms. We There've been a lot of very old electrophysiology studies where they put electrodes on the nerves and they look at how different nerve impulses are sent, which is how we understand how the synchronous and asynchronous flight muscles work and how some of the different turning muscles activate. So we do have a pretty good idea as to how that works. I don't know that we could do that specifically from the brain because it's more we just know how things connect together and we have some of those neurons labeled, but there is still a lot that we don't really know. Like we couldn't parse or process what a fly's thought might be. And again, not to be super self-promo with my work, but I have also made a Halloween video a long time ago called How to Build a Cyborg Beetle. How to Build a Cyborg Beetle is also another example of sort of freaky insect with electronics interface, where they took these I think it was Hercules beetles, and because they know exactly how the nerves interface with their flight muscles, they actually overrode those controls and they could make the beetles fly and turn and take off essentially using a remote control system.
Okay.
So I guess theoretically, yes and no. In some ways, we could do that already. And I don't feel like we're at that point right now with the connectome that we found, but I know that that's going to be a data set that is certainly going to be used to understand how signals are parsed in Drosophila
Mm.
neuroscience. So maybe down the line we will be able to.
Hey. Very interesting. Thanks for the question. If anyone has any more questions, let us know as we are slowly approaching D-Day. I have a sticky note with the questions as always. It's slightly different to the favorite bug question. My question is, if you were a bug, a fly, anything, which one do you think you'd be?
I've al- I've always joked as a kid that I would probably be a cockroach because they're really, really hardy and they have incredible reflexes. And maybe just in a very self deprecating way, I sort of identify with the Kafkian bug when I wake up in the morning because I'm
Wait,
not
like
a
as in Kafka's, what was it? Oh, what? Yeah,
metamorphosis.
Metamorph. Oh my God. What a flashback. Completely forgot
So
about that.
that's probably my disturbing answer. I'd probably pick a cockroach, but I guess having studied flies, if I wanted something more graceful and acrobatic, I would probably have to pick the hoverfly. I think my life would be longer if I was a cockroach. If I really wanted to live a long time, maybe a termite. Actually, termites have a pretty good life. They are lifelong, monogamous, live pretty well, have I think the largest colonies of any insect. So, if I had a desire to build a Pacific empire, I'd go for termite.
And they don't
And
tend to eat each other, do
male
they?
the male termite gets to live. They live
A
together,
win.
mate for life. They don't steal their endophallus. They're not jettisoned from the hive. So
Lovely.
companion for life.
So if there's if that question gets ever asked again to any gentleman in the chat, there is a bug there that you can choose where, you get to last past your purpose in life, if that makes sense. Um, you did a whole video about, obviously on YouTube you uploaded the about everything wrong with the Bee Movie, and I highly recommended you watch The Fly. Is there actually like a science movie that you watched, sci-fi, or read a book that you thought, you know what, this was actually good? This was actually not a bad
Ooh.
scientific movie or B movie. Well, not the B movie, but you know.
This is hard to say because I usually have to grant. I usually have to just accept the, get out of jail. This is sci-fi
Yeah.
card to a lot of things. There are certainly a lot of. I'd say they're more docudramas.
Mm.
I need to look up the name. In
Yeah.
Spanish, it's Las Lágrimas de Lorenzo. Lorenzo's Oil. That
Mm.
that one is accurate. It is about two parents who. Sorry, I need to remember the name of the condition. Basically, their kid has a neurodegenerative disease, adrenoleukodystrophy (ALD), which causes neurodegeneration, where signals stop being sent. Slightly different to ALS, and they did a lot of their own research and figured out that there was a certain type of oil that he could consume that would help slow down the progress of the disease, and they essentially kind of pioneered that field for him. I remember we were made to watch that in biology class, and again, more of a docudrama
Yeah.
than actually, a movie with a fictional tale, but I would say it's accurate. I enjoy movies that make you think about bioethics. So I recently watched Severance. You can
Oh.
argue there is a lot of sci-fi around the severance procedure, but I can see that the writers sort of tried to make some elements of it almost congruent, even if they don't go into too much detail about it. But it does raise, I think, in the viewer, it raises good questions about the bioethics around doing such things. Um, Gattaca, I would say, also falls under that category as well. Gattaca is one I should rewatch. It's been a while.
Okay, so we have a few lists there for anyone who's interested in watching some interesting, scientifically accurate, recommended uh, movies there. Spooky asks, would flies/bugs work in space? Is there any application for your work in space?
For my work specifically, not as far as I'm aware, but and again, I also have a video about this. There's a video on my channel, which is probably one of my favorites, called Five Things You Didn't Know About Insect Wings. And one that always strikes everybody is the fact that earwigs have inspired
Oh,
spaceflight. So you might not know, but earwigs actually have wings,
they
as
do?
most. Yep. They are
Okay.
extremely folded up. They have incredible wing origami, so they fold up into the tiniest of stubs. And they actually, researchers were so impressed by how efficient the folding was that they replicated this, I believe, for satellites. So they'll be able to, you know, launch their probes with the sails folded up and then copying the origami of the earwig wings. Then, when they need to be deployed, they can go from a very, very tiny and compact surface area
Oh.
to the full size.
That is so cool. I did not know that earwigs. Oh, earwigs. We mentioned earwigs recently on streaming. Completely forgot about that. Because it comes from the name earwig, that people would say that they could climb in your ears. Has nothing to do with that. That they climb in your ears and that they use those big pincers apparently. But we were scared into that as kids.
Yeah, I'm pretty sure the pincers are. So the female has curved pincers, the male has straight ones. No, actually, maybe the other way around. But I know that they use the pincers to grip the other one during copulation so that they are able to interface with one another. When in doubt, most adaptations in most
I was
organisms
gonna say their
are
whole
sexual
their whole
selection.
function is very sexy. Like it's their whole life is about it. Listen, we don't judge. We don't judge. Tarek says, speaking of movies, in the movie The Wicker Man, what would you recommend Nick Cage should do instead of shouting, "Not the bees"?
So I haven't watched The Wicker Man. So I don't know what happens
Okay.
at the point in time where not the bees has happened. But I like the meme of "I'm covered in bees," so maybe you could say that instead. I don't know.
There we go. There we
I
go.
need more information.
Official. A lot to put on your to watch list after today's stream. Thinking about flies in space, do you think their minds? Do you think their minds plastic enough to figure out how to manage in zero gravity?
Probably yes. So,
There's no air to
well,
flap though. Space, right?
they would they would probably be very confused.
Did we bring any
Uh,
flies into the International Space Station or anything like that? Because we did bring a bunch of stuff to test.
I don't know, but we probably have taken
Okay.
Drosophila. So they would be able to flap their wings. Some insects require input to flap their wings.
Mm-hmm.
So something I always say, let's pretend this is a grasshopper. If you grab its back legs and you make sure its front legs aren't holding onto anything, and you blow the front of its face, it has some little hairs on the front of its face which will make it open its wings and fly. So, if it has the input, my feet aren't touching anything, and there's air on my face. I am in the air. Therefore, I must flap my wings. That's a reflex that a lot of insects have. So that part might be lacking, which may confuse them, but also they wouldn't be holding on to anything, so they may try and navigate. I also know that, and again, this also pertains to another video that I made called "Why Are Bees So Fuzzy?" There is a piece of research. There was a study that Berkeley did where they were trying to find out if bees could fly under conditions where there would be less oxygen in the air or lower pressure, aka find out if, say, a bee could fly at the top of Mount Everest or not. And in essence, they are able to generate the lift in order to be able to do so. And despite the conditions being very, very different to how they would normally experience it, they are still able to replicate flight movements and respond. So I would say probably yes. And there's countless experiments that show that, the ways that insects fly, the way that insects hunt, the way that they interact with the environment is very, very plastic. Another story that I've it's a bit gruesome, but it's kind of funny in its own way. There was a lab that was studying how rubber flies. Rubber flies are a type of fly. They're a little bit larger, and they're predators that pluck other flying insects from the air. And so the student was trying to look at what parts of the rubber fly are essential to their flight. And one of the things that they did was remove the halteres, which, as we mentioned, are crucial for flies to be able to fly. So the supervisor, who was the one giving this talk, said, I felt like I didn't really. I kind of wanted to tell my student, don't remove their halteres because obviously they're going to need that to fly and to hunt. But sometimes it's good to make your students make their own mistakes. And what was interesting is even though they couldn't fly, in fact they were so useless without them that they would often be flopped on the side.
Oh no.
But they noticed that after a week the robber flies were still alive and there would be no way they'd be alive unless they were able to hunt. And so they paid attention and they realized that what the robber flies were doing, they weren't actually useless and flopping on their side. They were just playing dead. And so they would lay on their side. And then when the Drosophila melanogaster, which was what was being fed to them, would go nearby, they would ambush them from the ground without having to fly towards them.
Wow. When life gives you lemons. Or in this Jesus. And do you think that they I suppose my question is they must have known to do this, right? Because it wasn't just one fly that happened to uncover the secrets of hunting. They knew that if this were to happen, this is a way that they could hunt and survive.
Genuinely, I don't know
Oh.
if this was, innate
Mm.
instinctual behavior or if one of the flies did it and the
Taught
other
the
one saw,
others.
because they
Mm.
do have very good eyesight. They're not sociable, but apparently they would do this. So this became, novel hunting behavior in the robberfly in the absence of halteres.
Okay, that is really interesting. That they could pick up so quickly. I would feel like, flies and creatures like that, it takes a long time, generational, to kind of learn these things. But I'm surprised that in their own lifetime they can pick up new habits, if that is the case, or new tactics. But yeah, we are slowly approaching the end, I would say. I would like to outro by saying, was there anything that we didn't cover that, is a fun fact that you'd love to share? Or if there's anything that you'd like to end the stream topic with?
I don't think so. I mean, I can always talk the hind leg off a donkey on anything bug related. There wasn't anything specifically that came to mind. I am always very happy to answer any sort of question pertaining to insect flight. Like I can always go into more detail about aerodynamics, but it's also, pretty pretty technical and jargon heavy at times.
Yeah. So if you guys are interested, there are amazing YouTube videos, Draw Curiosity. If you hover over their name in the title, it'll actually give direct links. So if you guys want to follow. Another small thing is if you guys have additional questions and you're a bit shy to ask me, because I know I'm very scary, what we'll do is we're going to go into the AFK screen in a couple of minutes. And what we're going to do is Draw Curiosity is actually going to go live then, and we'll raid into their stream. So that way, if you guys have any more follow-up questions or any concerns, you can definitely go in that direction. If that's okay with everyone, how do we feel about that? All good? But yeah, what we'll do is I'll go into an AFK screen behind the scenes and I'll give some time Ines to, set up everything and to get everything up and going. But I'd like to say a huge thank you to my community for being so well behaved, for the incoming new community for being so lovely, and thank you so much for all the questions that you guys had asked. But yeah, make sure to give a follow. We have a shout out there coming out soon. And of course, also make sure to check out the YouTube because I think the videos are great. I already have 2 videos tabbed open that I'm interested in seeing. My quest to see the sun's surface is the one that, has caught my attention.
That was the turtle solar eclipse.
Oh, okay. I need to check it out. Thank you for the TofuTechTalk. Thank you so much for guys for hanging out. I'll try to get a guest at least every 2 weeks. But over the summer, hopefully every once a week while academic, life is on the quiet end. But yeah, thank you so much.
Thank you so much for having me on. And I'm sure my community who's joined in is already following you, but if you aren't, follow Tofu.
Yeah, you better. I mean, bye guys. Goodbye, everyone. Bye-bye. Bye-bye.
Bye. Thank you for having me.